Have you ever wondered how scientists and engineers measure the electrical properties of components like coils? One of their secret weapons is the RLC bridge. RLC bridges help us understand a crucial concept called impedance. Impedance is like resistance but for AC circuits. It tells us how much the component resists the flow of alternating current. An RLC bridge is a special type of electrical circuit. It's named after the components it measures: resistors, inductors, and capacitors. These components are found in almost every electronic device you can imagine. By using an RLC bridge, we can figure out the values of resistance, inductance, and capacitance in a component. So why is measuring impedance so important? It's crucial for many applications. For example, engineers use impedance measurements to design and test filters for radios and televisions. They also use them to ensure that components meet specific quality standards in manufacturing. Knowing the impedance of a component helps us predict how it will behave in a circuit. This knowledge is essential for designing and troubleshooting all sorts of electronic devices. Without RLC bridges, our understanding of electronics would be incomplete. Now let's dive into how RLC bridges actually work. Imagine a seesaw. You want to balance it perfectly, right? That's precisely what we do with an RLC bridge. We have a known impedance on one side of the bridge. Then we connect the unknown impedance, like our coil, to the other side. By adjusting variable components in the bridge, we try to balance it. When the bridge is balanced, we know the exact value of the unknown impedance. But wait, there's more. We have different types of RLC bridges, each with its own specialty. The most common ones are the series RLC bridge and the parallel RLC bridge. The series bridge is best for components with low resistance and high reactance, while the parallel bridge is better for the opposite. For measuring inductance specifically, we have the Maxwell bridge and the Hay bridge. Each bridge has its own advantages depending on the frequency range and the desired accuracy. The sharing bridge is another type, but it's mainly used for measuring capacitance. By choosing the right type of RLC bridge and carefully balancing the circuit, we can accurately measure the impedance of various components. Ready to try out an RLC bridge yourself? It's like solving a puzzle. First, we need to gather our tools: an RLC bridge, a signal generator, and a null detector. The signal generator provides an AC signal to the bridge, and the null detector helps us find the balance point. Next, we connect everything according to the chosen bridge configuration. It's like following a recipe, but instead of flour and sugar, we have resistors, inductors, and capacitors. Calibration is crucial before we start measuring. We use known standard components to make sure our bridge is accurate. Now, the exciting part. We connect our coil to the bridge and start adjusting the variable components. As we get closer to the balance point, the null detector will show a smaller and smaller signal. Once the signal is as close to zero as possible, we've found it. Finally, we can read the values of resistance and inductance directly from the bridge dials, or calculate them using the known components. It's like solving for X in an equation, but instead of numbers, we get valuable information about our coil. Remember those RLC bridges we talked about? Well, technology never sleeps. We now have advanced instruments called LCR meters that make impedance measurements even easier. These digital marvels automate the entire process, giving us fast and accurate results. LCR meters use a direct connection method. They apply an AC signal to the component and measure the resulting voltage and current. From these measurements, they calculate the impedance, along with other parameters like the dissipation factor and the equivalent series resistance. But before you rush off to build circuits, remember safety first. Electricity can be dangerous if not handled properly. Always de-energize circuits before making any connections. Use insulated tools and leads to prevent electrical shock. And most importantly, never work alone in the lab. RLC bridges and LCR meters are indispensable tools for anyone working with electronics. By understanding their principles and following proper safety precautions, we can unlock the secrets of impedance and design amazing electronic devices.